Okay, here we go. Simplifying radicals. What is a radical? We need to start with that. What is a radical? A radical is a square root. And in order to truly understand simplifying radicals, we need to first start out with perfect square numbers. So what are perfect square numbers? Here are some perfect square numbers. Let me put them right there. It's a perfect square number list. So you have 1, 4, 9, 16, 25, 36, 49, 64, and it continues forever, okay? How did I get these numbers? 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 times 7, 8 times 8, 9 times 9, keep going forever. So one thing that we need to know is that the square root of a perfect square number is a perfect answer. So what I'm trying to say is, if you have any of these guys inside here, you get a nice, beautiful answer, right? The square root of 9 equals 3. The square root of 25 equals 5. The square root of 64 equals 8. So it doesn't matter what perfect square number you have in there, you're going to get a nice, perfect answer when you take the square root of a perfect square number. So when do we hit a speed bump? When you take the square root of a non-perfect square number. Like, for example, the square root of 8. That is definitely not up here. 8 is not up here, right? Like, the square root of 9 is 3. The square root of 4 is 2. That's awesome. But the square root of 8, well, we don't know it. So the thing is, 8 is not a perfect square number. What you want to do is break it down with multiplication to get a perfect square number. We want a perfect square number in here, and this is not a perfect square number. So I'm going to break it down and rewrite it as 4 times 2, okay? And now, what we need to know now is this simple rule. Let me get this out of the way. This simple rule that when you have the square root of a number times another number, you could actually do the square root of the first number times the square root of the second number. So you could actually split the root, okay? And that's what we're going to do right here with the square root of 4 times the square root of 2. We're going to split the root, and we could actually do the square root of 4. That equals 2. And the square root of 2, we're just going to put it right at the end because there's nothing else to do with the square root of 2. So the square root of 8 actually simplifies down to 2 square root of 2. So I've cleared the screen to make more space here. Once again, this rule is what we're focusing in on right now, that you could actually split the two numbers, make the square root of the first one, square root of the second one, and actually simplify. So for example, let's say I had the square root of 32, okay? Now, it's not a perfect square number. If it were 36, the answer would be 6, but it's not 36, it's 32. So 32 is definitely not a perfect square number. What we want to do is break it down with multiplication so we could actually get a perfect square number in here. And you're probably thinking 4 times 8 is 32. But if you take a couple of seconds longer and look at higher perfect square numbers like 9 times something give you 32, it will not work. 16 times something give you 32? Yeah, 16 times 2. So if I break it down to 16 times 2, and I split the root to each of them, the square root of 16 is 4, and the square root of 2, you can't do anything with it, that's already simplified, so your final answer is 4 square root of 2. Okay, so I hope we get this. We've done this before. There's also something else that we've done. Whoops. What else have we done? We have also used this rule. Let me clear the screen. There we go. And let me get this one out of the way here. Now let's focus in on this one. This one says when you have the square root of a fraction, you could, just like multiplication with division, which is a fraction, you could split the root also. So let's say you did have the square root of 4 over 9. Okay, so you could split the root and have the square root of 4 over the square root of 9, which becomes 2/3, and that's your final answer. Pretty easy to do. Now sometimes it doesn't work out that easy. For example, let's say I had the square root of 4 over, let's say, 5, okay? And you split the root, the square root of 4 over the square root of 5, and the square root of 4 does equal 2, But the square root of 5, you can't really simplify it, so you have the square root of 5 on the bottom. Now the problem is this: you can't have a radical in the denominator. So we need to get rid of the square root of 5. You can never leave a root in the denominator. So I need to get rid of the square root of 5, and how do I do that? I don't know if you guys remember this from class, but to get rid of a radical, you could multiply it with itself, and the radical disappears. So I want to multiply both top and bottom by the square root of 5. So what's my final answer here going to be? It's going to be 2 square root of 5 over 5, the square root of 5 times the square root of 5, which is really the square root of 25, which takes you back to 5. So now there's no more square root on the bottom. That's your final answer. Radicals are kind of like variables. You can combine like terms. You can multiply anything that's not alike. Okay, so what am I talking about? Let's say I had a 2x plus 3x. Well, you could actually combine those because they're like terms, which means you have a total of 5 x's. So what do I mean by that radicals are kind of like variables? Well, if you had like 2 square root of 5 plus 3 square root of 5, it's kind of like if you had 2x plus 3x, and you would get 5x as an answer, but in this case 5 of these square roots of 5. Okay, so radicals are kind of like variables. You could combine the ones that are alike. Now check this one out. Let's say I had a 2x plus 3y, and I told you to add that. You can't add that. It doesn't work, right? It doesn't work. And likewise, if you had 2 square root of 5 plus 3 square root of 7, you cannot add that, right? Just like variables. These terms are not alike, so you can't add 2x plus 3y. You would just leave it like that. These radicals are not alike. This one's a square root of 5, this one's a square root of 7. You cannot add them. You would leave them like that. What else? Let's say I did have a 2x times a 3y. Could we multiply those? Heck yeah. It would be 6xy. Okay? So you could actually multiply variables that aren't alike. So that means that you could also do the same with radicals. 2 square root of 5 times 3 square root of 7. You could actually multiply them together. Just like up here, we multiplied the 2 times 3, we could also multiply the 2 times 3, and that'll give us 6. And the square root of 5 times the square root of 7, you could actually do that. You could actually multiply them together, because the rule could be used backwards. You remember how we used to split the roots? You could actually put them together and say 5 times 7, which would be 35. So that would be your answer on that one. Now, of course, you're supposed to try to simplify the square root of 35, but when you think about the perfect square numbers, 4, 9, 16, 25, none of those could be used to break down 35, so that's as simple as it gets. So just a little more practice here. Radicals, they're kind of like variables. So if I told you to do 2 plus the square root of 3, and I told you to simplify it, that's as simple as it gets. You cannot do anything to that. Or how about this? Let's say I had 3 square root of 2 plus, let's go with the square root of 8. Okay, well, could we add these? Could we add 3 square roots of 2 with 1 square root of 8? No, because they're not like terms. However, whenever you do have a square root, you're supposed to try to simplify it. So the square root of 8, we know, breaks down to 4 times 2, and we split the root, and we'll get 2 square root of 2. So what we really have is 3 square root of 2 plus 2 square root of 2, and that's kind of fun because the 3 square root of 2 came down, the square root of 8 was rewritten as 2 square root of 2, and now we actually do have 3 of something plus 2 more of that same something. It's kind of like saying 3x plus 2x. So we could actually get the answer here, 5x, but not 5x, it's 5 square roots of 2. Okay? Remember how we used to distribute binomials? Like let's say you had a x plus 2 times a x minus 3. It's really easy to do, right? You go x times x, that's x squared. X times negative 3 is negative 3x. 2 times x, that's positive 2x. 2 times negative 3 is negative 6. And of course we combine like terms. So that's x squared minus 1x plus, actually not plus, it's minus 6. Sorry. Anyways, why did I do that? Just to help you understand this next part. Right there we multiplied variable expressions, a binomial times a binomial. And we're saying that radicals are kind of like variables, kind of like variable expressions. So what I want to do is I want to say, let's say 2 plus the square root of 3, which you can't really do because you can't add numbers and radicals, kind of like you can't add numbers and letters. You can't add 2 plus square root of 3. But I am going to multiply it by, let's say, 3 plus the square root of 2. Okay, now you might be thinking, what the heck's going on? It's really the same exact process as up here. All right, all the stuff that we did up here, we're going to do the same thing here. Let me clear and make some space for it. Here we go. So I'm going to multiply 2 times 3. That becomes 6. 2 times the square root of 2. That's kind of like saying 2 times x. It's going to be 2x. But in this case, it's going to be plus 2 square root of 2 instead of 2x. And then we have the square root of 3 times 3. And that would be positive 3 square root of 3. It's kind of like saying x times 3. That would be 3x, right? And last but not least, the square root of 3 times the square root of 2. And the square root of 3 times the square root of 2 is positive, because positive times positive is positive. And the square root of 3 times the square root of 2, you could actually multiply those together and put them together underneath one square root, and that'd be the square root of 6. So ladies and gentlemen, that would be our answer for the binomial 2 plus the square root of 3 times 3 plus the square root of 2. And there's nothing else to combine. If you think about it, this is like a 2x, this is like a 3y, this is like a z or something like that. You can't combine any of those. So let me clear this and do one more final example. If we take a look at the example of x plus 2 times x minus 2 and we distribute, something interesting happens. X times x is x squared, x times negative 2 is negative 2x, 2 times x is positive 2x, and 2 times negative 2 is negative 4. The interesting thing that happens is that the middle terms cancel out, right? That's when you have the same exact binomial, but one's a plus and one's a minus. So something interesting also happens when you multiply a radical with its conjugate. That's the first time I mentioned that word. The word conjugate is when you have the same binomial, but the middle term or the middle sign changes. So let me give you an example of that. So right here we have 3 minus the square root of 2, and I'm going to multiply it by the conjugate of 3 minus the square root of 2. And the conjugate of 3 minus the square root of 2 would be simply 3 plus the square root of 2. Okay, that's something that we need to know, the word conjugate. And it's simply taking a binomial that has a number and a radical, and you change the sign. And anyways, we're going to see that when we distribute, something interesting happens here also. So when we go 3 times 3, you get 9. 3 times square root of 2, we get 3 square root of 2. Square root of 2 times 3, but you have the negative square root of 2 times positive 3, you get a minus 3 square root of 2. And minus square root of 2 times positive square root of 2 is going to be a minus. Square root of 2 times square root of 2 is the square root of 4, which takes you back to 2. I hope we all understand that. So we do end up with a minus 2 at the very end. So the interesting thing about this is that the middle terms is a positive 3 square root of 2 and a negative 3 square root of 2. They also cancel out. It's kind of like having a positive 3x and a negative 3x. So what ends up happening when you multiply a binomial with radicals times its conjugate, the radicals disappear. And you end up with 9 minus 2, which equals 7.